My question is following this. May I ask you about the architecture of LLM, transformer, the structure implementation, the realization of context of sentence. If then I assume execute the code of including transformer. Inputting the word is best is multi number of elements group as one token and that. Other element of including element is that. For example, in English token block, I will include a phonetic transcription word to a tuple on Python and really the normal way. Transformer including this way is fast and soon wrong. I see this case is experiment of code myself. Does this exist as the experiment anywhere? I ChatGPT answer is this. Uh, I see what you are asking. Let me unpack your question carefully. You are essentially asking transformers, the backbone of LLMs encode context across sequence. You tried feeding in compound elements per token, like a tuple. Um, in word and phonetic transcription. Instead of just word tokens, you notice in your experiments that learning seemed faster. You are asking whether this kind of experiment or idea exists in research. Let's break it down. Transformers and token representation. A standard transformer model, like GPT or BERT, takes as input a sequence of embedding where each xi in usually a single token embedding coming from a vocabulary index, but embedding can be argument. A simple example: concatenate concatenate multiple vectors per token. Word embedding, part of speech embedding, phonetic embedding, in IPA or some phoneme vector, or sum them into a single vector, common in BERT which add token plus position and segment embeddings. In your case, a tuple in word and phonetic is basically multimodal embedding per token. So the transformer now sees richer input per position. 2. Prior, prior research, similar experiment. Yes, similar ideas exist. 1. Multi-feature embeddings. Multi-feature embeddings. Some LLP models concatenate word embedding with morphological, syntactic, or phonetic embeddings. Example: Chinese Romanization models sometimes include pinyin embeddings with character embeddings. Speech-to-text transformer, like some variants of Web2TIC, Web2BIC plus BERT sometimes combine acoustic plus textual embeddings per token. 2. Multimodal transformers, VRBERT, creep, etc. Combine multiple modality, text plus images. Your idea is a micro multimodal word plus phonetic transcription. Faster convergence. Richer embeddings per token can speed up learning, because the model receives more informative signals for each position. This is why in your experiments it might have learned faster. 3. Combat. Simply concatenating tuple won't always improve performance. You need to align the dimensions, embedding vectors, properly, vocabulary size and tokenization still matter. If you treat in word and phonetic as a new token, in embedding tuple grows fast. Some researchers encode phonetic input separately and merge under the embedding layer, like summing or linear projection instead of creating a joint vocabulary. For summary, what you did is basically augmenting each token with extra features. Phonetic. This idea exists in research often under character phoneme embeddings, morphosyntactic embeddings, multimodal transformers, microscale, and yes, it can lead faster or better learning because the model sees the richer information pattern. If you want, I can draw a simple diagram of your idea in a transformer, showing in word and phonetic tuples as input embeddings and compare it with standard word embeddings that usually helps visualize why learning scale speed up. Do you want me to do that? Thank you.